Permutation. In this lesson, permutation of n objects taken r at a time. The number of arrangements of different objects taken r objects at a time is equal to n factorial over n minus r factorial. Note that n should be greater than or equal to r. Let's try to have an example. In how many ways can a president, vice president, and secretary be elected from Andrew, Brian, Charlie, Daryl, and Elmer? Since there are 5 choices for the president, vice president, and secretary, thus n is equal to 5. Since there are 3 distinct positions, it means that it will be taken by 3 persons out of 5. Thus, r is equal to 3. In our formula, permutation of n taken r at a time is equal to n factorial over n minus r factorial. When we substituted the values of n and r, we will come up to permutation of 5 taken 3 at a time is equal to 5 factorial over 5 minus 3 factorial. It is equal now to 5 factorial over 2 factorial. When we expand 5 factorial, we will have a product of 120. While the 2 factorial, we will just have 2. When we simplify this one, divide them all, we will have 60 ways. Therefore, our answer in this problem, there are 60 ways to elect the 3 positions. Let us see all the possible permutations. As you can see here, in each of the column and rows, there are possible people that can be elected as the president, vice president, and secretary. Let's try to come up in the first example. In this case, A is for Andrew, B is for Brian, and C for Charlie. Andrew is the president, Brian is the vice president, and C is the secretary. On the other hand, Andrew is the president, Daryl is the vice president, and Brian is the secretary. On the third permutation, we will have Brian as the president, Andrew is the vice president, and Charlie is the secretary. When we list down all of this one, we will still come up to 60 permutations. Let's try to have another example. There are 10 participants in the race. In how many ways can the first place, second place, and third place can be arranged? There are 10 participants. It means that n is equal to 10. Since there are only 3 places being considered, then r is equal to 3. So when we substitute the given value of n and r to the formula, we will come up to permutation of 10 taken 3 at a time is equal to 10 factorial over 10 minus 3 factorial. And when we simplify the denominator, we will just come up to 7 factorial. And when we expand the numerator, we will have 10 times 9 times 8 times 7 factorial. Instead of writing 7 times 6 times 5 times 4 times 3 times 2 times 1, we can write it as 7 factorial. As you can see here, there are common factors. 7 factorial and 7 factorial. 7 factorial in the numerator and 7 factorial in the denominator. So since there are common factors, we can now cancel them. In this case, you will have an answer of 10 times 9 times 8, which is equal to 720 ways. Therefore, the answers here in the given problem is 720 ways. It's about time to test yourself. I've prepared you two problems in these exercises. Each problem will be given 10 seconds to answer. Let's try to check your answers if they are correct. In our first problem, there are 15 hikers who participated in 2017 summer hiking event. The first, second, and third hiker to reach the top will be given 15,000 pesos, 12,000 pesos, and 10,000 cash prize, respectively. In how many ways can the hikers win? Since we have 15 hikers who participated, Rn is equal to 15. And since they are looking for the 3 positions, R is equal to 3. When we substituted the values of N and R to our formula, we will have 50 permutation of 15 taken 3 at a time is equal now to 15 factorial over 15 minus 3 factorial. When we simplify the denominator, we will have 12 factorial. And when we expand the numerator, we will have 15 times 15 times 13 times 12 factorial. Since they have the common factor 12 factorial and 12 factorial, they can be cancelled already. So the remaining numbers that can be multiplied is 15 times 14 times 13, which is equal now to 2,730 ways. In the second problem, a lottery has numbers from 1 to 45 mixed together in one circular container. How many possible permutations are available if there are no replacements and 6 balls drawn should be in exact order? Since we have 45 numbers, we will Rn is equal to 45. And since there are 6 possible orders that has no replacement, Rr is equal to 6. Therefore, when we change this to our formula, we will have the permutation of 45 taken 6 at a time. Thus, 45 factorial over 45 minus 6 factorial. Therefore, we will have 45 factorial over 39 factorial. When we expand the numerator, we will multiply 45 to 44 to 43, 41 to 44, 40, and 39 factorial. 39 factorial can be eliminated or can be cancelled already. Therefore, our answer in this given problem is 5,864,443,200 ways. That's it. That's the permutation of n objects taken at a time. Thank you.